Hi guys, in this video we're going to talk about reading instruments. This goes with Objective 6 in Unit 1. Objective 6 in Unit 1 is also about accuracy and precision, and so that's where we're going to start today. So let's get out our Cornell paper. So remember, the first thing you're going to do is fill out this over here, your name, class period, and date, and our topic is accuracy and precision, and we're going to have two essential questions. The first one is, what is the difference between accuracy and precision? And our second question is, how do I read an instrument? Okay, so we'll start with accuracy and precision. Now, accuracy is the easy one. People generally know what accuracy is. So let's go ahead and write that down. Accuracy is how close a measurement is to the actual value. If you think about this in terms of the game of darts, this is how close you are to the bullseye. Bullseye is the right place, anywhere else is not quite, so how accurate your measurement is how close you are to the bullseye. Now, precision is a little bit different. Precision is how close a measurement is to other measurements. This is pretty difficult to think about, but think about it in terms of the darts. If you throw a bunch of darts and they're close together, then that was a pretty precise throwing. Precise is not about how accurate it is, so let me show you a handy picture here. So this picture has a bunch of bullseyes, and it has a bunch of darts that have been thrown at them, and you can see where they're accurate or precise. And so let me draw some lines on here, on our little box here. Okay, so the ones on the left are not accurate, and the ones on the right are accurate. And you can see that there's also some difference. The ones on the top are not precise, and the ones on the bottom are precise. So remember, precise is how close they are. You can see that the darts in both this one right here and this one are close together. They're not far apart, so that's what makes it precise. But if you look here, these are nowhere near the bullseye, but over here they are on the bullseye. This one here, this not precise business, if you kind of point in the middle, see there pointing in the middle, that's pretty close to the target, so that's actually pretty accurate even though the measurements are all over the place. So that's what we're talking about there. Now when it comes to tools, when we're thinking about tools that we use to measure, their accuracy and precision is kind of dependent on the tool itself. Accuracy is going to depend on how good you are at using the tool, and precision is going to depend a little bit more on the tool itself. So let's take a look at some graduated cylinders on the next page. You can draw this picture of the targets on your paper. Just feel free to pause. I'm going to go ahead and go on to the next page though. So here we have some graduated cylinders to look at, and we're going to talk about how to measure those. But they have some different scales on them, so how we look at them is going to be a little bit different. I'm going to jot a little note down here about precision in a tool. Precision in a tool. Whoops, my eye got stuck together there. Alright, so precision in depends on the increments, and the increments we're talking about are the little distances between these lines here. So to get from one line to a next, that's an increment. The smaller the increments are, the more precise the tool is. And think about it this way. If I give you a ruler and it has a mark here and a mark here, and we've got something measured that is this long, and you have to estimate where that is. Maybe this is 5 and this is 6. Well, maybe Johnny says that it's 5.6, and Sue says that it's more like 5.7, and some other kid comes in and he says, no, that's more like 5.5, and another kid says, no, that's more like 5.6, or whoops, not 6. He says it's more like 5.62, and so we're getting a bunch of different answers here. But if I then go back and I put some little tick marks on here, you can see a little bit more clearly where that actually is. So the increments make it more precise because you and a bunch of your friends are more likely to write down the exact same number for the measurement. So that's why we call the increments a little bit more precise. So let's talk about how to read these graduated cylinders right here. I'm going to, well, maybe I can't. Okay, so let's take a look at this top one here. I'm going to go ahead and zoom in on it. You can see first off there's this little thing right here that is called the meniscus, kind of like what's in your knee that sometimes gets hurt if you play a sport. It is a curved thing and you always measure from the bottom of the meniscus bottom. That's where you're going to be measuring from. So this goes from 60 to 70, so what I need to do is I need to think about how big the increments are. If I could label these, that would be 61 and 62 and 63 and 64 and 65, and there's 66. I can see that the bottom of the meniscus is right there at that 66. So this measurement would be 66, and because I can tell it's right on that line, I put 0.0. 0.0 tells me it's right on there. If you know for a fact it's right on that line, you write 0.0 after your measurement. Or in the next one I can show you what happens if it's right in between some other numbers, but we'll see. There's always an extra 0 if you know it's on a line, okay? If it is between the lines, you're going to estimate to the next one out. So let's take a look at this on the next one here, if I can get it to move. There we go. Okay, so this one is not quite on a line. If I take a look at it here, I've got 8 and 9. So to think about my increments, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there's 10 increments. So these are going to be 0.1s. So that's 8.1, 8.2, 8.3, and so on. My bottom of the meniscus, I think if I zoom in a little bit more, can I zoom in a little bit more? Oh, there it is, nice and big. Okay, the bottom of the meniscus is right there. It's not on either of those lines. If it were on the line above, that would correspond to 8.7, and if it were on the line below, it would be 8.6, but it's not on those. Do you think it's about halfway between? To me, it looks like it might be a little bit more than halfway in between, especially when I zoom in like this. If I didn't have the ability to zoom in, I might have picked maybe 8.65, but what I'm doing is I'm estimating the next number. If it was right on the 8.7, I'd put 8.70. If it was right on the 8.6, I would put 8.60, but it's in between. So I'm going to put 8.6, and to me it looks a little higher, so I'm going to go with 8.66. And that's probably milliliters on that graduated cylinder. So that's my estimate. So this one, I could see that it's above the 8.6 and below the 8.7. This one here is the one that I estimated. Now, let's take a look at one more. If I can zoom in and find it. There it is. Okay, so here, this one has a strange scale, okay? Here I've got 30 here and 35 there, and how many little lines do I have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that tells me that this would be 31, and this would be 32, and here's 33, and here's 34, and that takes me up to 35. This is how you would read a scale. If you're not really sure, just try and put some labels on there so that everything is evenly spaced out. So I see that the bottom of my meniscus is right here on this line, and that line is halfway between 32 and 33, so that's going to be 32.5, and since it really looks like it's right on the line to me, I'm going to put 32.50 milliliters. When it's right on the line, add a 0. If it's on the line, add a 0. Okay, maybe it's a 0.0, maybe the 0 goes on after another number. Either way, you're adding a line. Now when you do this with centimeters, it works exactly the same. Figure out what the increment is, add a 0 if you need to. Now what's really fun, and you've already seen this because you've probably already done a lab here, when you measure mass, you put the stuff on the balance, and then you simply read all the numbers. You don't round, you don't change anything, you don't leave anything off. You write down every single number that's there. It's so easy. All you have to do is write the whole thing down. And that's how you measure mass. All right, so get cracking on that homework, take the quiz, let me know if you have any questions. Thanks for watching.